Good day to all of you. My name is Remington Schmidt, and I'm going to be talking today about the Bernoulli Brothers. So, the Bernoulli Brothers are really famous mathematicians from the 17th and 18th century, and many of the generations within the Bernoulli family were really impressive mathematicians. They really worked on a lot of important issues and buried themselves in solving some of the most difficult problems of the day. They surrounded themselves with smart people. But in particular, the Bernoulli brothers, Jakob and Johann, are famous for their unfailing support for Leibniz and his calculus, and kind of them being initial calculus gossips, as well as their kind of work with probability statistics and infinite series. Newton and Leibniz really invented calculus, but Johann and Jakob were determined to shout calculus out to the world, and I personally found the Bernoulli brothers really interesting because of how dramatic they were. In some ways, they act almost soap opera-ish in terms of how math history went down. So if we take a first look into Jakob Bernoulli, who was the older brother, Jakob Bernoulli was originally going to be a clergyman. That's what his father set him up to do, but he really found joy in mathematics. And he was, like I said, he was the older of the two brothers, and he left kind of a big mathematical mark on history. He had some small contributions to calculus. He made some developments on what Leibniz said. He really clarified a lot of points. He puzzled over sums, his infinite series. We're going to talk about that a lot later. But he also did a lot of independent work with probability and combinatorics. He wrote a book at one point, Ars Conjectandi, which was actually published posthumously or after his death by his nephew Nicolaus. This book in English would be called The Art of Conjecturing, and really set the foundation for lots of modern parts of probability and stats. And it includes a version of the law of large numbers, as well as ideas of combinations, permutations, and expected values. In this work, he made a few references to a lot of different people, so Huygens with the cycloid, Cardano, Fermat, Pascal, and that's just a few of the people that he really mentioned and used in his works. His younger brother, Johann, really established a name for himself in kind of a different way. He was a staunch supporter of Leibniz, ready to jump forward and protect all of Leibniz's ideas, kind of like Huxley was for Darwin, and so that's why they kind of gave him the name Leibniz's bulldog. Johann was really gifted in understanding calculus and was really responsible for the rapid spread of calculus across Europe. He learned it all from his brother, but at the end of the day, it was him who was kind of the connoisseur of calculus. Leibniz and Newton had finally published their works, but both were kind of unpopular, not really well read. They were kind of tossed together. But some of the people that really understood this was the Bernoulli family. They sat down and they learned calculus, and they really started to make a lot of broad applications that they were able to kind of make. And one mathematician who was kind of amateur was Marquis de la Hospital, and he was desperately interested in learning calculus. And he was rich, and so he harvested Johann's knowledge of the subject so that he could learn it for himself. And so Johann would present him with a lot of information about calculus, papers and such. And after a while, La Hospital collected a series of papers that Bernoulli wrote, and he published the book Analyse de infinitesimes petits, or The Analysis of the Infinitely Small. And this work hit the public with a much greater force than did Isaac Newton's or Leibniz's work, and that really cemented Johann's name. Just as kind of a fun fact, while he was learning calculus, Johann Bernoulli was actually a medical student on his father's wishes, but that was only because he wouldn't agree to become a merchant. And after a while, he kind of ditched his plans to become a medical doctor, and he kind of just focused on math, and that was after the death of his father. You couldn't let people down back in those days. But the relationship between the two brothers wasn't really very congenial. It was really, really rocky and really competitive. So both brothers fought over the coining of the term integral. So in both works, two different brothers used the word and they claimed it for themselves. They certainly worked together on a lot of different subjects. Jakob was largely responsible for teaching Johann math, but Johann eventually became Jakob's equal on the playing field. They really puzzled over a lot of the same problems. They competed with each other to find solutions, and they would claim intellectual superiority over the other in the event that one found a solution before the other. At this time in Europe, when a person discovered a problem to which they didn't have an answer, they would pose that problem really publicly. And that was what we saw a lot of times with the relationship between Johann and Jakob. So one example of this is the hanging chain problem. So Jakob Bernoulli posted this question publicly. He said, what would the shape of a curve drawn out by a chain hanging under its own weight when the ends are connected to points A and B? What would be the curve curved out by this chain that you see here? If you held it up at the ends, what would the curve look like? And Galileo in the past looked at this problem and he just kind of assumed that the shape would be parabolic. That's what it looks like at first glance. But Jakob really could not find a solution, and he was struggling. And so he posted this question publicly, and after just a day, Johann Bernoulli came up to him, and he said, I have the solution, haha, look at me. And upon submitting his solution in paper, Johann remarked, I think this was kind of like the antithesis of humble, but it was really funny anyway. So he said, the efforts of my brother were without success. For my part, I was more fortunate, for I found the skill, and I say it without boasting, for why should I conceal the truth, to solve it in full. It is true that it cost me study, that robbed me of rest for an entire night, but the next morning, filled with joy, I ran to my brother, who was still struggling miserably with this Gordian knot without getting anywhere, always thinking, like Galileo, that the catenary was a parabola. Stop! Stop, I say to him. Don't torture yourself any more to try to prove the identity of the catenary with a parabola, since it is entirely false. While this may seem a slap in the face to Jakob, the writings of the Bernoullis was often this way. In some ways, it seemed playful in kind of a back and forth way. So, one thing that they did manage to work together on, though, was the harmonic series. And they kind of contributed equally, actually. They displayed a lot of brotherhood during this work, something that we have observed that was not especially strong with them a lot of the times. Originally, Leibniz was famous for his treatment of summing infinite series, but his solutions were more clever than they were really comprehensive. He deduced things about the series through additive manipulation rather than really providing legitimized proofs. And so, the treatment of harmonic series, like 1 plus 1 half plus 1/3 plus 1/4, so on, was one that a lot of people puzzled over. What happened with it? The Bernoullis were not the first people to reach the decision that the sum was infinite, but in Jakob's work, the Tractatus, which was one of his most famous productions, the treatment of divergence and convergence made a huge impact on modern math. So this is one instance in particular where the two brothers would not have been really considered genius without each other. There's a lot of times when people look at the Bernoulli brothers and they say they're talking about both of them. They never talk about them really independently, and that's because in order for you to have really a comprehensive discussion of what one Bernoulli brother did, you have to have information about the other. And so in Tractatus, it was Jacob's work, or Jakob's work, but he cited Johann as being the one who came up with the proof for the divergence of this series. And he made the observation the sum of an infinite series whose final term vanishes, perhaps is finite and perhaps is infinite. And this wasn't really, it wouldn't be respected by today's standards, but we understand quite what he's saying. So, another thing that they looked at was something called the brachistochrone curve. And if you look at that and you break it down, brachistos in Kronos is Greek for the shortest time. And fun fact, Kronos is the ancient Greek god of time. So I suppose Titan would be more appropriately put. And so what this question was is Jakob sat down and he said, okay, I've come up with a solution to this problem. Now I'm going to present it to you as kind of a challenge. And so the question was, if 2 points existed, A and B, where B was lower than A, but not directly under A, what would be the fastest curve for a ball acted upon by gravity to take from A to B? So how could we get from A to B the fastest if we were to draw out a line or a curve? And he gave people 1 year to give him submissions. After a while, the Leibniz wrote him back and said, I need a little bit more time, man. So he extended the deadline to the Easter of the following year, and in just under 2 years, Jakob had received 4 submissions other than his own. One was from Isaac Newton, who was actually, they sent him the problem directly, and it was kind of insulting almost. They wanted to see if Newton could really do this, if his calculus was going to live up to Leibniz's standards. And so Newton actually, kind of understanding this, he sat down and he did it in one night and he sent it back, and his answer was right. Johann Bernoulli, to Jakob's chagrin, also came up with a solution. Leibniz came up with his own solution, and L'Hospital came up with solutions. So all the people that we've been talking about, really, came up with solutions. And this was kind of one of those really sort of interesting moments in history where everyone who knew the calculus well was able to come up with a solution, but it really baffled everyone else. So they left kind of an interesting legacy behind. Not only did they spread calculus throughout the world, and they were really responsible for understanding a lot about infinite series, the convergence and divergence, but they also left behind kind of a generational impact. So Johann Bernoulli's son was Daniel Bernoulli, who was perhaps even more famous than Johann Bernoulli for his unique work with fluid mechanics and his stuff that he did with conservation of energy. Johann had a really rocky relationship with Daniel as well. It was just about as peaceful as it was with Jakob. And there was one instance where Daniel was able to solve a problem during a math tournament that Johann was unable to solve. And so Johann kicked Daniel out of the house in kind of a really sportsmanlike way. Um, Johann Bernoulli was the teacher also for Leonhard Euler at a very young age. And in nearly every way, Euler eventually outstripped his teachers. We know that he worked with sums of infinite series, and he's kind of the poster child for what a great mathematician is in history. But he ultimately owed a lot of his education to the Bernoulli family. What we can say for sure is that the Bernoulli brothers were certainly a lot to handle, and they were very dramatic between each other. But despite their unconventional nature and the way that the relationship was built, the inexplicability of it all, they were very successful in leaving their mark on history. So here are the citations if you want to follow up with anything, and I hope you enjoyed today's video.